All right, welcome everyone to our first video of remote teaching. So we're going to begin in chapter 8. So we're right up here in section 8.1 of our textbook. And we're going to be learning about something called a sequence. And in this video, I want to just explain what a sequence is, give some examples of sequences, and talk about some of the things we could want to do with them. So this is our definition from the textbook. It says a sequence can be thought of as a list of numbers written in a definite order. We can underline that. And the number A1 is called the first term, A2 is called the second term, and in general, when we see this A sub n, that's called the nth term of our sequence. And so I've got some room. When we write down a sequence of numbers, there's really no rules. All that has to do is we just have to have an infinite list of numbers, and they have to be in some order. So for instance, I could talk about the sequence like 1, 2, 1, 2, 1, 2, 1, 2. It just keeps going and alternating. And I would talk about this first sequence. This first term would be A1. This next term would be A2. This one would be A3, etc. So a sequence is really just a list of numbers. Another thing we could do is we could think about like the digits of pi. We could do 3, 1, 4, 1, 5, 9, 2, and keep going through there. This would be another example of a sequence. So in this case, this would be the first term, this would be the second term, this would be the third term, right? And so I want to just point something out at this point, is that with the first sequence, if we go up here and think about this first one, if I asked you what the millionth term of this sequence was, I think you'd be able to do that. Because I think you'd notice, well, it's either going to be 1 or 2, and every even-numbered term is going to be 2, and every odd-numbered term is going to be 1. So you would probably be able to say that a million is going to be equal to 2 in this case. Now, if I asked you what's the millionth term in this sequence down here for the decimal of pi, well, that would be a lot harder, right? I don't know it. I'd have to look it up and ask a computer. And so finding later terms in the sequence might be easy if we know a pattern, and it might be really hard if we're not sure of that pattern. Okay, so let's just look at some examples, right? So sequences come up all the time. For instance, we can talk about, say, the population of the world in year n, right? So we go all the way back to the year 1, and then the year 2 and 3 and 4, and now we're to the year 2020. And just think about what the population was at January 1st, right? So that number, that's probably going to be a bunch of numbers. It would be increasing. Right now we know P, P sub 2020, that's our current year. And the world population in 2020, I'm looking it up right now, is roughly 8 billion people. Right. And so this is one way that sequences kind of come up in our lives. Example B is one maybe we've seen before, where we have the nth decimal place of a number. And so for instance, E, if we look at the digits after the decimal point, we get 7, 1, 8. We can think of that as a sequence. Or, and maybe you've seen this before, there's something called the Fibonacci sequence, which is a sequence of numbers where the first term in the sequence, so here we're calling the sequence Fn instead of An, and so we're going to have like F1, F2, and then rather than saying what F3 and F4 are, we give this formula that says Fn is Fn minus 1 plus Fn minus 2. And so in other words, what that says, and let's work that out, that would say F3 is equal to F2 plus F1, right? If I want to know the next term, fn, I just take the term before it, and I add the term before that. So let's work it out. So that would be f2 plus f1, so that's 1 plus 1, that's 2. F4, I guess, well, that would be f3 plus f2. That would be, I guess, f3 is equal to 2. f2 is equal to 1, so that would be 2 plus 1, that's 3. And we see this nice pattern, right? And maybe you're able to do it a little bit faster just by looking at these numbers. So we've got 1, 1, 2, 3. The next one's going to be 2 plus 3 is 5. The next one is going to be 3 plus 5 is 8. And the next one's going to be 5 plus 8 is 13. And we just carry that through. So these are all examples of sequences. They're just numbers in order. And now I guess let's just look at one more set of examples here. So here, we may have a formula for the nth term of our sequence. So let's just focus up here, right? So really this is communicating the same information. It's saying that the nth term of our sequence is going to be n divided by n plus 1. And so this is kind of in a different notation. We just kind of emphasize that n could start at 1 and could go all the way up to infinity. So if I look now and I say, well, what would happen if n is equal to 1? Well, that would say a1 is equal to 1 over 2. So that should mean the first term of our sequence is 1/2. Let's see. And the second term, well, if we want a2, that should be 2 over 3. That's right. And in general, we kind of get this nice pattern. Okay? And so when we have sequences, sometimes we'll have a formula for the nth term. And then what we do is we just plug in that value for n in order to get that number. So let's do an example where we work it out. So suppose I wanted to find the first 5 terms of this sequence here, where an was equal to n squared plus 5. Well, if I wanted to find the first 5 terms, I would just let n equal 1. If I let n equal 1, that's 1 squared plus 5, that's 6. If I let n equal 2, I guess that's going to be 4 plus 5, that's 9. Okay. If I let n equal 3, that's going to give me a 3. That's going to be 3 squared is 9, plus 5 is 14. A 4 is going to be 16 plus 21. 16 plus 5 is 21. And a5 is going to be 30. Okay. And so I'll put a ... because that sequence goes on forever. And that's how I can find the terms in my sequence. Okay. So sometimes we have to go backwards, and I think you have a few problems on your homework where you have to do that. And so I wanted to solve a few of those. So let's do one here. Let me make this font a little bit smaller. So here's a sequence. We're given a first few terms of it, and we're asked to find a formula for the nth term, an. So I look at it and I say, well, what's the pattern? Well, I have 11, 14, 17, 20. It keeps going. It looks like it goes up by 3 each time. Right? It looks like I'm adding 3. And so what I might do, I might say, well, you know, this really kind of seems like I just started with 11. And then what did I do? I did 11 plus 3. And then I did 11 plus 3 times 2. And then I'm basically adding a 3 each time. Right? And so let's just guess. Let's just try a guess. We'll see if it's right. So I think what's going to happen if I want the nth term, then I should just do 11. And then I'm just going to add a bunch of 3's. Right? So let's try adding 11 plus 3n and see what happens there. Now if I check it, in this case, it would say a1 is equal to 14, a2 is equal to 17, a3 is equal to 20. And that's not quite right. right? Because I wanted the first term to be 11, and I wanted the second term to be 14, third term to be 17, and I'm off. You see how I'm off by, really I want this to be the second term. Okay? And so how could I adjust that? Well, I just have to subtract 3 from everything. So if I go through and I subtract 3 from all of these numbers, then it will adjust everything back to how I want it. Right? And so that was kind of a trial and error. Let me just simplify this. So by trial and error, I came up with this formula for an equals 8 plus 3n. And I think that's the way I would approach it, and that's the way I encourage you to do it, is just try to kind of see what's happening. So let's do another one. Let's do another one and see what happens. So maybe you want to pause the video on this one and see what you would do on this one, right? So we're trying to find a formula for the general term an of that sequence. And we look at the terms. We've got 3/5, negative 4 over 25. So the first thing I do is I look at those denominators, right? I look at that and I say, well, a1 is 3 over 5. a2 is, I guess, negative 4 over 25. If I look at those denominators, they appear to be powers of 5. And so, like, one thing I could do is I could rewrite a3. That's going to be 3 over 5 to the third power. Okay? And so I'm looking at that and I'm saying, well, an appears to have the nth power of 5 as its denominator. So that's a pattern I noticed. And now the numerator, well, let's see. Well, when n was 1, let me change my color here to red. When n was 1, our numerator was 3. When n was 2, our numerator was 4, but with a minus sign. And when n was 3, our numerator was 5. So I look at that and I see the pattern. Well, it looks like it's just 2 more. So it looks like I just want to add 2 to n. So n plus 2. And let's see. So when n is 1, it's going to give me a 3. When n is 2, it's going to give me a 4 and a 5 for 3. And now everything is right except for the pluses and minuses. And so the way I can get that is I can just multiply the whole thing by negative 1 to some power, right? So let's see how this goes. So if I multiply by negative 1, let's say to the nth power, then what is this factor gonna do? Well, if n is odd, this is going to be a factor of negative 1. So this is going to make all the odd terms in my sequence negative. And we look over and we say, well, do we want the odd terms positive or negative? Well, I guess we want the odd terms to be positive, and we want the even terms to be negative. And so the easiest way to achieve that is instead of multiplying by negative 1 to the n, let's just multiply by negative 1 to the n plus 1. Okay? And so this is just a trick. You'll get used to it as you're working in this course. But if we multiply by negative 1 to the n, makes all terms, all odd terms negative, and negative 1 to the n plus 1 will make the even terms negative. Okay. So this is a way to kind of adjust the signs. And so for our final answer, we have that this is our formula for an, and this is now pretty nice, because now if I asked you what would the, say, 10th term or 100th term of the sequence be, you could very readily calculate that just by plugging in n equals 1,000,000. And I could ask you questions like, what happens as n goes to infinity? What would the limit be as n gets really, really large? And that's what we're going to talk about in the next few videos. So thank you for watching, and talk to you soon. Bye.